Welcome to Ask an Engineering Manager, where we answer your questions about work, life, and career as a developer or a manager in the software industry. So let's get started and discuss today's topic, which is: which language is the most useful to learn? That, of course, depends completely on what you mean by most useful. So I'm going to give you a few definitions of my own, then cover all of them, and you pick whatever definition you meant, and then you have your answer. So what could be meant by the most useful language to learn? Firstly, and most obviously, it could of course mean it's the most useful to build an application in. Or it could mean it's the most widely used language, as in the most useful to get a job. Or most useful as in learning it will make you a better programmer. Or maybe you're just starting out and you want to know what language is most useful as the first language to learn programming. So, definition number one. Which language is the most useful to build an application? Well, there my first question to you would be, do you already have a specific application in mind that you want to build? Because which language you're going to use is most often not determined so much by the merit of the language, but predetermined by what platform you're building for. That usually means what device or operating system is your application supposed to run on. For example, if you want to develop a mobile app and you want it to run on iOS, then you definitely have to know Swift and maybe a bit of Objective-C, at least passive to understand Objective-C code. But these days, pretty much all new apps are Swift. So if you want to build an iOS app, it's pretty much Swift or nothing. The same with Android. These days, Kotlin is the language of choice. You probably should still know some Java, again, at least passively. And yeah, I am aware of the fact that there are other options. There's all kinds of things where you can, call out to C or native code, or even get something like Python to run as an Android app. Yeah, these all exist, but it's not the kind of thing you would want to use in production unless you have a very specific need or use case. Well, the one exception is, for both mobile platforms, web programming could also be useful with things like React Native, where you can wrap a React app as a native app, or even things like Ionic, where you have basically just a giant web view inside your native app. But I would say, especially if you're learning, you should learn the native platforms for mobile. Pretty much the same thing applies to desktop applications. If you want to build for Windows, it's pretty much .NET, and .NET pretty much means C#, which is actually not a bad language at all. So good choice. And again, you could do Java, but that's never quite native. You could do scripting solutions, but again, if you have a real desktop application that's like heavy on UI and user interaction and integrating with the operating system, then it's pretty much C# for Windows. Likewise, for the Mac, it's pretty much like iOS technology-wise, Swift or Objective-C. On Linux, it's a bit more difficult because, there's so many flavors of Linux. It's probably still C++ with either Qt or GTK. It's not really my area of expertise, but that's probably still a good choice. Of course, there's all things like Tickle, TK, and all kinds of other GUI toolkits. Rust is getting more popular in the open source community, and so on and so forth. Then when you're building an application, maybe you're not even building for a specific operating system, but for a platform. These days, there's a lot of things that are applications really, or started out as single applications, but have also become development platforms with a huge plugin ecosystem and partner solutions and so on. This is especially common in the business enterprise world, where you have things like Salesforce, which started out really as a CRM, but really it's kind of like a database plus UI that you can define yourself on the web. And really you can really use it as a development platform, in which case Salesforce says you pretty much have to use Apex, which is what Salesforce calls their more or less Java in different clothes language. And then, of course, you have also ERP software like SAP, where it's in practice usually still ABAP that you're going to use to program that. And a lot of enterprise software, things like a PIM, DAM, CRM, CMS, all those three-letter applications, they usually have some kind of plugin functionality where you can extend them. And that usually means writing a plugin in the same language that the application, the host application itself is written in. That, of course, depends on the application. By far the most common are either Java or PHP. And even if you don't program or don't plan to develop your app for a specific platform or a specific platform application, often within a certain domain, a certain class of application, there's really one language that's king or just one or two that are the obvious choices. Some examples here are, if you're doing machine learning, you are very probably doing it in Python or maybe in Java, but you certainly won't do machine learning in Go, no matter how much you like the language Go. Same with things like systems programming. If you're doing operating system kernels, you probably need C. If you're doing any kind of Internet of Things where you're really working on the devices themselves, small scale networked sensors, that kind of stuff, anything that's more or less embedded programming, that is still probably mostly C. And then there's also a couple domains where, for example, everything that could be described as infrastructure, especially things around the whole Docker and Kubernetes ecosystems, that is really most likely to be Go. So that's not set in stone. You have a choice, you have other options, but usually it makes sense to go along with whatever is the most popular, like the most popular 2 or 3 languages in your domain. Not only because that means there's a lot of plugins and libraries already available for your library, it also means it's probably a good choice. You might notice that I have not talked at all about how good the language itself is in terms of language design, because those things I mentioned usually trump that by far. But still, let's assume you just want to know in general. You do not have a specific application in mind. You'd want to know what's the best language to build applications in apart from any platform. And even there, it's not about the language. It's by far more about the whole ecosystem. Most importantly, the availability of libraries, preferably open source libraries, because they're easier to debug, but also because they're free. Not just because, it's good to not pay money for something if you don't need to, although you totally should support maintainers of open source libraries that you depend on. These days, there are many of ways, sponsorship, donations, buying support, that kind of thing. But still, buying things is a hassle often in large enterprises, so anything we can just use without having to ask anybody is good. So a large ecosystem of open source libraries is a good thing. Because no matter how good the language is, you will never be as quick to write an HTTP client yourself as having a choice of 5 ready-made libraries you can just use. Now, even when we're not talking about a specific application or domain, it should still be common to use the language that you're going to use for your purpose. Simply because if you're writing a web app, it's a million times easier to Google for whatever problem you're having plus Ruby on Rails than it is to Google for your problem plus Swift, simply because the vast number of people using Ruby on Rails for web apps is a million times larger than the number of people using Ruby on Rails for Swift. So chances are, if you use Ruby on Rails and you do anything on the web, somebody else already has had your problem, and if you're lucky, has already solved it and posted a solution to Stack Overflow. With Swift, probably not so much. The common saying for that is, use boring technology. If you're excited about using technology, that probably means it's new, that probably means it's coming up, it probably means it's not common, which means it's not established, and you will find all the edge cases yourself, whereas boring technology is tried and tested, and you can really focus on building your app rather than having bloody fingers because you come up against cutting edge technology. Or another good way to say it is, never be the largest deployment of anything. To put an example, if you're using MySQL, you are probably smaller than Facebook, so Facebook probably has come up against any scaling problem you might have with scaling MySQL. So there will be a solution to that you don't have to find yourself. And that's always a good thing if you can focus on building your app rather than solving technology problems that somebody else could already have solved for you. From a strategic point of view, it should also be popular in the future, because the more popular a language is, the more people are learning it, the easier it is to find people who know that language, who can get on board and then just have to learn your application without having to learn the language first. One example, Scala looked like a really good language if you were starting a new project in, say, 2010. Nowadays, if you have a code base in Scala, well, it's not that easy to find programmers who know Scala. It's not that big a deal. It's fairly easy to learn if someone has, for example, a Java background. But still, if you had picked a language that turned out to be more popular in 2020, then it would be easier to hire someone to get on your project. And finally, the thing you've been waiting for, properties of the language itself, where I would say the most important property of the language is that it makes you productive. That means it's not about the type system. You can argue for days, or if you're an academic, for years, careers, about whether dynamic or static typing is more important or better or more productive or safer or whatever. It does not matter in reality. I think the trend these days is back to static typing or more type safety, or at least a little bit of type safety, but you can be perfectly productive in both kinds of languages. It's also not about the syntax. I mean, these days, most modern languages look pretty much alike, at least on the surface anyway. Most are somewhat C-like. There are some outliers like Objective-C or Erlang that look really weird syntax-wise, but it does not matter. You get used to any kind of syntax. It's also not really about the features. Things like functional programming is nice, but I would say it doesn't really matter. There's a famous article by Paul Graham where he says he attributes the success of his early e-commerce startup to the fact that they were using Lisp, and said, okay, the language made us much more productive, and that's why we had a successful startup. Honestly, I don't buy it. I don't think productivity of writing a language has never been as important as having an ecosystem of tools, of libraries, of support, of a large community of people who are working on it. That is what really makes you productive. And last but certainly not least, I would even say most important point when picking a language to write a new app in, if your goal is not to learn a new language, but to get the app done, then use whatever you know the best. It doesn't even matter if it's the best choice for the app you're doing, especially if it is somewhat supported on the platform that you're going for. It doesn't matter if it's cool, it doesn't matter if it's new. Just use what you know well, because if you're focused on building an app, learning something new, learning a new technology stack, a new language at the same time will just slow you down. Of course, if you're building a hobby project, a side project where the main purpose is to learn, then by all means pick something new that you find exciting, that will expand your worldview. But then probably don't expect to finish that side project, or at least not very soon. But if you focus on the building something, pick whatever makes you think about the language and the technology the least. So, talking about get things done. Now let's say second definition of most useful language to learn. We actually want to get a job. So what do we do for that? I've already mentioned before a lot of platforms that pretty much predetermine the language. So pick a popular platform, learn the language for the platform, boom, you're pretty much set in terms of jobs being available. And you should actually look at that, because there are a lot of languages that look really cool and are really popular in programmer circles, but don't actually have much of a job market, or a really shrinking one. So for the language to get a job with, we want to be able to do lots of different things with it, hopefully not be constrained to one industry, one domain, one platform. There should be a large number of jobs out there for people working in that language. And of course, since we are now treating it as an investment, it should be a good long-term investment. So we do not want to pick a language that's currently declining where no jobs will be available anymore in 5 years. So firstly, there are several options tied for third place that will probably surprise you. Number 1 for third place is C. Yes, C, low-level old school C. Why? Because it's still king of the hill for lots of embedded programming, especially things that are close to electrical engineering. So if you're working for a company or you want to work for a company or you have a degree or a background that could more be described as electrical engineering than software development, pick C. Second choice for third place is PHP. Yes, PHP, probably the most uncool language, the one that most people will make fun of you if you're a PHP programmer. But you know what? There is a ton of PHP projects out there and a ton of PHP jobs. Now, typically the PHP projects are the one that start out small as like an amateur project, a prototype, and then they grow. So they're not always the best architected, the best maintained. But these days, PHP has a lot of good language features, a lot of good frameworks. So a modern, well-done PHP application is not necessarily bad at all, quite the opposite. The one limitation of PHP is that it's only for the web. So you have to know that you want to do web stuff if you learn PHP because you want to go for that kind of jobs. And option number 3, I just said PHP, the most uncool language. Well, no. Third option is the really most uncool language, and that would be Visual Basic. Yes, I mean that. Why? Because Visual Basic is probably the most used language in the world for Microsoft Office macros, especially things like Excel. So if you would describe yourself not as a programmer, but as a marketer or manager or salesperson, I would advise you to actually pick Visual Basic and learn that as a first language. It is intended to be easy to get into, and you will get immediate use out of it. Like, there is probably not a single marketing or salesperson or manager in the world who would not be better at the job if they knew Visual Basic, especially for Excel. Keep in mind, that's not a good language. If your goal is to eventually get into programming software development, you will probably have to unlearn some bad habits that Visual Basic has taught you, but well, that can be done. Now, for my real first and second choice to learn a language to get a job with it, my first choice would still be Java. Again, rather an uncool language these days. I like to think of it as the VW Golf or the Toyota Camry of programming languages, by which I mean that it has few enthusiasts. Nobody, or not many people, would describe themselves as being super passionate about Java and thinking Java is the best language in the world and most exciting. It's probably not, because Java is not the best at anything, I think. But no matter what you want to do, it will be competent at it, and it will be a good choice and a solid choice, and will be decent and scalable and performant enough, and has a huge ecosystems of libraries and tools because it has been around that long, and also because it has always been adjacent to the whole open source scene much more than, say, C#. So it's really common for libraries to be open source, to be widely available, to be somewhat standard. It's pretty much also the default for SDKs and integrations. Like, if you offer SDKs for whatever you are building, you will probably offer a Java SDK at least as one of the options. It's also huge in the enterprise. Like the saying used to be, for enterprise use, it's either Microsoft Stack or Java. I would say Microsoft Stack less these days. But Java is still definitely a very, very big thing in the enterprise. And what people like to forget, it's incredibly battle tested, as in the Java virtual machine, as in the platform that your Java programs actually run on. has probably seen the most investment of pretty much any piece of software to ensure that its performance is good and it's scaling and it's stable. And last but not least, Java is relatively easy to learn. It has a bit of craft because it's been around a while, and Java has this thing where they usually need 2 tries for every framework until a good one comes along. And they usually have this thing where there's a so-called JSR, like the official Java spec, to do things one way. And then it turns out not to be that great. And then an industry standard comes along, as in what people actually do. That's usually from the Spring world. So you often have those 2 worlds or 2 solutions for every domain. But it has a really big ecosystem. It has really good IDEs, really good compilers. It's a bit big itself as language, not necessarily elegant, but it is very sane, very logical. It was designed to be pragmatic, to be practical, to be relatively easy to learn, to be relatively well designed. And it's simply not a language for snobs, but it is a very good language for everyday programmers who just want to get stuff done. And the second choice, probably the most obvious choice these days, is JavaScript. JavaScript used to be this toy language for the browser, and you can still see that today a little bit by still having some weird corners, some design flaws from back in the day when it was supposedly designed within 2 weeks by a guy at Netscape. If you want to have some fun, Google for YouTube JavaScript what or WTF, and you will find some funny stuff. But it doesn't really matter that much these days because it has undergone a huge evolution, especially ES6, like all the modern specifications are called ECMAScript, and ECMAScript 6 has been out now for long enough that it has become standard and it's pretty much supported everywhere in all the browsers. But that was a huge change to the language that fixed and cleaned up and extended a lot of really important things with the language, and it still keeps getting better. There's improvements all the time. And it's also not confined to the browser anymore. If you want to do server applications, well, there's not a lot of choice. It's pretty much Node or nothing, or Dino these days, which is pretty much the same as Node architecturally. You can also do desktop applications with stuff like Electron, with things like React Native. You can even have mobile apps. And at its core, it's still a quite small and simple language. And, well, more and more applications are moving to the web. These days, you almost have to justify building a desktop app and not just doing a web app. So there's this famous quote by Joel Spolsky saying, "Never bet against JavaScript." And yeah, I would second that. It's getting ever more performant. It's getting better all the time with things like the aforementioned ECMAScript standards, and also TypeScript, which is basically a superset of JavaScript where you have a type system on top of it, is becoming really popular and is really good. And like I said, it's supported on ever more platforms. So to sum up, if you want to get a job, the 2 obvious choices, Java and JavaScript. By the way, if you haven't learned them yet, completely different languages despite the similar names, but both good choices to learn. Now, definition number 3. Which is the most useful language to learn when we define most useful as the best in the terms of learning it will make you a better programmer? Well, that would obviously be PHP. Nah, I'm joking, of course. Although I only have joking PHPs, I have decent language these days. But when we want a language for making us a better programmer, we want a language that is considered good, as in language itself, as in it is consistent, it is well designed, and I would say for learning it's also good if it's somewhat pure in terms of principles and designs. You probably don't want a language like Java that is object-oriented, but not really that object-oriented because it has some crafty old areas and has some functional areas these days and so on. You probably want something that embodies a certain principle. I would say if you're learning a new language to make you a better programmer, the best language is whatever gets you out of your comfort zone the most. Because if you want to grow, you have to do something different from what you've done before. So, for example, if you've only ever done web applications, maybe do some desktop or mobile applications. Or if you want to go even further, do something completely different like embedded applications. Maybe get a little Arduino board and program it in its little language. Or if you've only ever done backend stuff, learn some front end, learn some JavaScript, some CSS, whatever. Or the other way around, if you're a front end developer, learn about things like scaling and concurrency and database design and stuff like that. And also, it's a really good idea to learn something that embodies a different programming paradigm. For day-to-day use, you probably use something object-oriented like Java or C#. So pick something different. Pick, for example, Erlang, which is not only completely different syntax, but also completely different design, a very functional language. Or maybe you've always used comfortable languages, like languages that were designed to be easy and programmer friendly, like Ruby or Python. So maybe go more low level, try your hand at C, or go even more low level to assembler, because the point here is not to have a language to be productive. And the point here is to learn and to expand our worldview of what programming can mean. So go weird by all means. In general, I would say if you have the time, I would say it would be good to pick one language of every major category, to learn that, to have that in your tool belt, where the major categories are firstly object-oriented languages, where the practical choice would be Java. The purist choice, if you want to learn object-oriented principles, would probably be Smalltalk. Then secondly, to use a functional language, where again, the most practical choice these days, it's not terribly common, but it sees quite a bit of use in certain areas, would be Erlang, which is also great to teach you about concurrency. Or if you want a pure implementation of a functional language, of course, the choice would be Lisp. Not something you will use for productive use probably, but really great to learn. And then thirdly, something like a nice little scripting language, something where you can automate things, maybe interact with the operating system, depending on how easy you want to make it on yourself, either Python or maybe Bash scripting. And then lastly, like I mentioned before, if you're looking for pure learning, don't be afraid to go weird. Pick something that's completely different from what you're used to. Maybe pick an assembler if you've never done it and you haven't been to university or haven't covered it there. Something you will almost certainly not use these days, but is really good to know as a fun exercise and to expand your worldview. Or maybe also something like Prolog, which is a completely different form of programming again. So go have some fun. All right. All that assumed that you already know how to program. So what do you do if you've never programmed before, but you want to learn programming, and you're asking yourself, which is the best language to learn programming? So what do we want in the first language to learn? First of all, of course, it should be not too hard. So that rules out, for example, C, because C is quite a hard teacher, especially in the beginning. It should also not be too complex, which rules out, of course, stuff like C++. I remember my first try at programming was when I was 12 years old. I grew up in a small town. Back then, the internet did not exist. So where did I go to pick up a programming book? I went to the local library. And my local library in the early 90s had basically 2 books on programming. There was Basic for the C64, which I didn't have. And there was a book on C++. I have never failed so hard at something as trying to learn C++ with absolutely no previous programming experience from a single library book, so do not pick C++. Before I mentioned, if you want to expand your worldview, do pick something weird, but for learning your first language, do not pick something weird. Where weird would mostly mean functional languages like Haskell or Lisp or Erlang. Yeah, I know they have the fans. Lots of people really love functional programming languages. I would still say it's not a good language as a first language because a plain old, somewhat imperative object-oriented language is just much easier to reason about as a first language. But it is great to learn one later to expand your tool set. It should also not give you too many bad instincts, bad principles. It should be somewhat well designed. So please do not use Visual Basic. We had an example before where it makes sense, but generally, if you're serious about becoming a software developer, like a full-time developer, do not start with Visual Basic because it will not instill good habits. I would say not even visualbasic.net, which these days is a real language, unlike, say, the old Visual Basic 6, but still, just don't. It should also not be just a toy language, because I think if you really want to learn programming, you should be able to do real applications in it. There are all kinds of environments and languages that are designed to be easy to get into for kids, to like pick up a few basic principles of programming, like Logo, this language where you move a turtle around the screen, or even like the Lego Mindstorms environment. These are really great for kids. If you're not a kid anymore, if you're like high school, university age, I think you can pick up a real language and you can go further with that. You should also not pick a language that's outdated, because while you're learning something, you might as well learn something that's actually useful in the real world. For example, Pascal was a great teaching language. It was actually my first language, but I would not use it as a language learning anymore today because it's simply completely outdated. And lastly, I think it's good if your teaching language is freely available. For example, C#, you pretty much have to buy Visual Studio as your programming environment to do that. I think there's pretty good free editions these days also, but then it also only works on Windows. Or if you want to go into Swift, it is open source these days, but it's very much tied to the Apple ecosystem. So use something that's freely available, that runs on all the major platforms. It doesn't tie you to any paid tools or environments. So now we had a lot of things like what not to pick. So what do I recommend to learn? Well, things like PHP or JavaScript or Java would all be decent choices. But my recommendation would be, as a learning language, pick Python. Why Python? It's pretty easy because Python is one of those languages that were designed to make it easy as a programmer, that really care about usability, that have coherent design, that makes sense. One thing I really like about Python is also that it has really good error messages, because that really makes a big difference, especially when you're starting out. You write your first significant program, and then of course, it doesn't run on the first try, so you get an error message and you have to figure out what is wrong. It is really demotivating when you get an error message that basically tells you nothing but, there's an error somewhere. So good error messages make a difference, and Python is usually pretty good at those. And it's also popular with non-specialists, like for example, scientists who are not full-time programmers often use Python. So there's also a lot of like user-friendly guides and things intended to get you into Python as your first language if you don't know yet how to program. I would say Python's also pretty well designed. It is also quite an old language, but it does not have that much old cruft. There was bit of a messy transition between major versions Python 2 and Python 3, but that is long enough in the past that I would say that's over by now. So when you start, make sure you pick a current version, 3 or later. And you can also go quite far with Python because it is object-oriented. It has a few functional principles. You can use it for scripting. And there's a wide range of real applications, because one of the things that's really motivating when you're starting out is when you do not spend too much time learning about like the pure principles of programming, but when you're building something with it. And Python can be used to do web apps. It can be used for scripting tasks. It can be used for machine learning, for scientific computing. So it's really easy to get started. You can just, call up Python on the command line, type a command, run it. You don't need a lot of heavy tools. You don't need to write big programs. You can literally start a Python interpreter with one command and then type a single command and see it run and see what it does. And that's really easy to get started. But if you need more support because you want to write bigger programs, there's also a lot of toolings like real development environments available. I already mentioned before that it's really motivating to do something, to see your results. So that would be the most important advice. If you want to learn programming, find the project you want to do. I mean, you have to learn the principle. You have to learn, what is an array and the list and the function and all that. There's no way around that. But then once you have the basic down, find something to do with it. Might be as simple as writing your own to-do list or vocabulary trainer or a blog engine. It doesn't have to be super useful. It doesn't matter if 1,000 others of that kind already exist. Just make something yourself. So pick something that you have a personal interest in that maybe relates to a hobby. Also something that's small and simple enough that you can actually get it done in the beginning. And then just try doing this. And then learning by doing, you will pick up more principles and more things. Probably by doing it wrong the first time, but hey, we're learning here. And that way you get to build something and run something and see it happen. And that's a really good way to feel the joy of building something up from nothing. And well, just see if you catch the coding bug. Good luck. Thank you for listening to this episode of Ask an Engineering Manager. To get your question answered, send it by email to askanengineeringmanager, all one word, @gmail.com, and we might answer it next time.